Well, welcome back to Classmen. Today's notes, we'll be talking about section 6.4. We're going to be looking at rectangles. I'm going to give you the definition. The first definition that we're going to study today is that of a rectangle, which is a parallelogram with four right angles. So if I look over here to my figure at the right, I need to put in the markings of that of a parallelogram. So here I know that my opposite sides are parallel. So I have two pairs of opposite sides that are parallel. And it has to have four right angles. So I'm going to put in the four right angle boxes. So that lets me know that I have a rectangle. So looking at the definition of a rectangle, I know that it has all the properties of a parallelogram. So a rectangle has opposite sides that are congruent. That was one of the first properties that we've learned about a parallel. A second property that we learned about a rectangle is that it has opposite sides parallel. We know that a rectangle will have opposite angles congruent. If I was to draw in the diagonals in this rectangle, I know that a rectangle will have diagonals that bisect each other. That's another property of a parallelogram. And finally, a rectangle has consecutive angles that are supplementary. So we know that consecutive interior angles will be supplementary. So we've studied all of those about parallelograms. There is one more property of a rectangle, and that's theorem 6.13. It says if a parallelogram is a rectangle, then I know that the diagonals are congruent. So let's look at our first example today. It says I need to find the length of this diagonal, or just a diagonal. So here I see I have quadrilateral SBFR, and I want to know what is the length of the diagonal. So that means SF is a diagonal, and I also know that RB is a diagonal. So that means because these are diagonals, it's a rectangle, they are going to be equal to each other in length. So 2x plus 15 will be equal to 5x minus 12. So I'm going to add 12 to both sides. I get 2x plus 27 equals 5x. I subtract the 2x from both sides, and I get that 27 equals 3x. Divide both sides by 3, and we get that 9 is x. But I'm not finished. I didn't ask you to find the value of x. I needed to know what is a length of one of these diagonals. So SF is equal to 2 times 9 plus 15. I get 18 plus 15, 18 plus 15, that's 33. So the length of a diagonal is 33 units. Taking a look at our next example, I said if LN is 4x minus 17, and MO is 2x plus 13. What are the lengths of these diagonals? So here I know that MO is equal to LN because these are diagonals. If you wanted to, segment MO is congruent to segment LN. And now that I know that they are congruent, that means they are equal in length. That's probably the best way to state it. So that means LN equals MO. So 4x minus 17 equals 2x plus 13. I'm going to go on and solve for the variable x. So I'm going to add 17 to both sides. I get 4x equals 2x plus 30. Subtract the 2x from both sides. That gives me that 2x equals 30. We divide both sides by 2, and that gives me that x is 15. Again, I'm not finished. This time I'm going to plug it in for segment MO. So 2 times 15 plus 13. 2 times 15 is 30 plus 13 is 43. So a diagonal here is 43 units. Looking at my third example, it's going to be this rectangular garden gate is reinforced with diagonal braces to prevent it from sagging. It says if JK is 12 feet and LN is 6.5 feet, find KM. So JK is this length up here. I'm just going to go on and put it in the problem. It's telling me that JK is 12 feet, so 12 feet. And then it tells me that L to N is 6.5 feet. Find KM. Well, because this is a rectangle, I know that it's got to be a parallelogram as well by definition. So the length from L to N is 6.5 feet, which means that the distance from J to L is equal to 13 feet. JL is a diagonal. I know that MK is a diagonal, or KM is a diagonal, and because diagonals of a rectangle are congruent, KM is 13 feet. You're probably asking yourself, Mr. No, why do they give me this JK? It's just extra info, so it is not really needed to solve the problem. So went ahead on the next example and labeled the given information. So I know that GH is 6 feet, it's labeled, and F to H is 15 feet. It is a rectangle, so if it's a rectangle, I know it's a parallelogram. So I know that the distance from F to J is half of 15 feet, which is 7.5 feet. So that means JH is also 7.5 feet. But because this is a rectangle and I know that the diagonals are congruent, that means that the diagonals will also bisect one another. So that means E to J is 7.5 feet. And that means that G to J is also 7.5 feet. So GJ equals 7.5 feet. Let's look at our next example here. It says quadrilateral RSTU is a rectangle. If the measure of angle R to T to U is equal to 8x plus 4. So I'm going to highlight that angle R to T to U right there, and it's telling me that that angle is 8x plus 4. And then it says the measure of angle SUR is 3x minus 2. So I'm going to highlight this angle, S to U to R. And they're telling me that that angle right there is 3x minus 2. So 3x minus 2. So 3x minus 2. All right, so we're kind of in a little predicament. I don't have the whole angle. I can't set this triangle equal to 180 degrees because there's a couple angles that I do not know. But let's go back to our diagonals. Know that RT and SU, the diagonals, are congruent. And because it's a parallelogram, that the diagonals bisect each other. So because they're congruent and they cut each other in half, this is what I get. I get two isosceles triangles. I know you probably can't see it, but this guy right here, triangle RPU, is isosceles. So if that is an isosceles triangle, then that means that this angle PRU is congruent, right here, is congruent to this angle, PUR. So this angle PRU is also 3x minus 2. Now I'm good, because I could take a look and I could take and see that triangle TUR right here, this yellow triangle I highlighted, I have all that I need to know. I know one of the angles is 8x plus 4 right here. I know that angle is 8x plus 4. So this guy right there from here to here. I know that this guy from here to here is 3x minus 2. And I know that this angle right there is 90 degrees, the measure of angle TUR. So I'm going to say 8x plus 4 plus 3x minus 2 plus 90 equals 180. So you could go on and combine your like terms. I'm going to get 11x plus 4 minus 2 is plus 2, plus 90 is plus 92. And that equals 180. When I subtract the 92 from both sides, I get that 11x equals 88. Divide both sides by 11, and I get x equals 8. Okay, I changed this problem up last second, so guys, you're going to need to change your example and put in the numbered angles here. I did give you one angle, and that is the measure of angle JEF, and I'm telling you that that's 70 degrees. So take a moment and copy the angles down in your notes. You may want to pause the video. Okay, I'm assuming that everyone paused the video and has taken an opportunity to copy these numbers down. So looking at our picture, I was told that the measure of angle JEF is 70 degrees. That's all I need. I could find all the rest of these angles in this picture based off of 70 degrees. Okay, I'm going to start off with what I know, and that is that these diagonals, GE and FH, they are congruent and they bisect each other. Well, since they're congruent and they bisect each other, I'm going to get all kinds of isosceles triangles in here. So I get triangle JFE as isosceles. I get triangle GJF as isosceles. I get triangle HJE as an isosceles triangle, and GJH as isosceles. There's one thing I know about all the angles of a rectangle. This guy is a rectangle, and that is that the angles, so GHE is 90 degrees, H to E to F is 90 degrees, and that's where I'm going to start. Because I know that that is a 90 degree angle, I know that this angle right here is 20 degrees. And because these triangles are isosceles, that means the legs are congruent, which means that these base angles right here are congruent. So if this angle is 20 degrees, that means the angle up here, that is angle JHE, is also 20 degrees. And because a triangle adds up to be 180 degrees, I've got 20, 20 and 20 is 40. 180 minus 40 is 140 degrees. So that means the measure of angle 3 is 140 degrees because they're vertical angles. And because these two triangles are congruent, these base angles will also be congruent. So that means angle 6 is going to be 20 degrees. And that also means angle 4 is going to be 20 degrees. So I'm going to come back to these triangles right here. Triangle JFE and triangle GJH. If this angle is 70, remember these legs are congruent. So therefore the angles, the base angles, will also be congruent. So that means that this angle down here is 70 degrees. 70 plus 70 is 140, which means that this angle is 40 degrees. Which means angle 2 is 40 degrees because of vertical angles. So then I know that angle 1 is 70 degrees and angle 5 is 70 degrees. Why do I know that? Again, these triangles are isosceles. So therefore, I have to have base angles that are congruent. I have 2 of them. This angle is 40. So all the angles in this triangle add up to 180. 180 minus 40 is 140. 140 divided by 2 is 70 degrees. So we found all the angles. We're done for the day. I appreciate you guys watching my video. I hope you enjoy the homework and you can move on with confidence as you go through it.